Top 10 RabbitMQ interview questions for freshers 2024. Gain insights into message queuing, asynchronous communication, and RabbitMQ's features and use cases. What is RabbitMQ, and what are its use cases? RabbitMQ is an open-source message broker software that implements the advanced message queuing protocol, AMQP. It enables asynchronous communication between different applications or components by providing a reliable and scalable message queuing system. RabbitMQ is widely used for decoupling applications, implementing task queues, distributing workloads, and building event-driven architectures. What are the core components of RabbitMQ? The core components of RabbitMQ include exchangers, receive messages and route them to queues. Queues, store messages until they are consumed. Bindings, rules that determine how messages are routed from exchanges to queues. Producers, applications that publish messages to exchanges. And consumers, applications that consume messages from queues. What are the different types of exchanges in RabbitMQ, and how do they work? RabbitMQ supports 4 types of exchanges. Direct, routes messages based on exact match of routing key. Fanout, broadcasts messages to all bound queues. Topic, routes messages based on pattern matching of routing keys. And headers, routes messages based on message headers. Each exchange type has different routing strategies and use cases. How does RabbitMQ ensure message durability and reliability? RabbitMQ provides several mechanisms to ensure message durability and reliability, including durable exchanges, messages are persisted to disk. Durable queues, messages are persisted to disk. Publisher confirms, publishers receive acknowledgments for persisted messages. And message acknowledgments, consumers acknowledge message delivery. What is the difference between RabbitMQ and other message queuing systems like Apache Kafka? RabbitMQ and Apache Kafka are both message queuing systems, but they have different architectures and use cases. RabbitMQ is focused on providing a reliable, scalable, and flexible message broker for asynchronous communication between applications. It supports a wide range of messaging patterns and protocols. Apache Kafka, on the other hand, is primarily designed as a distributed streaming platform for handling high-volume, real-time data streams. It emphasizes throughput, scalability, and fault tolerance for large-scale data processing pipelines. How can you monitor and manage RabbitMQ clusters? RabbitMQ provides several tools and plugins for monitoring and managing clusters, including RabbitMQ Management Plugin, web-based UI for monitoring and administration, RabbitMQ CTL, command line tool for managing nodes and clusters, and RabbitMQ Prometheus and Grafana integrations for monitoring and visualizing metrics. Additionally, RabbitMQ supports clustering and high availability configurations for fault tolerance and load balancing. What are RabbitMQ Shovel and Federation plugins, and what are their use cases? The RabbitMQ Shovel plugin allows you to move messages from one RabbitMQ broker to another, effectively acting as a message replication or routing tool. The Federation plugin enables you to create a single logical broker by linking multiple RabbitMQ brokers together, providing features like message distribution and load balancing across brokers. How do you handle message retries and dead letter queues in RabbitMQ? In RabbitMQ, message retries can be implemented by configuring a dead letter exchange, DLX, and a dead letter queue, DLQ. When a message cannot be consumed or processed successfully, it can be automatically routed to the DLQ by the DLX. From the DLQ, the message can be retried or handled separately. RabbitMQ also supports setting a maximum number of retries and configuring retry intervals. What are RabbitMQ security features, and how can you secure your RabbitMQ instances? RabbitMQ provides various security features to secure your instances, including authentication, username and password, or external authentication sources like LDAP, access control, virtual host and resource level permissions, SSL, TLS encryption, for secure communication, and plugin access control, restrict plugin installation and usage. What are some best practices for designing and implementing RabbitMQ-based systems? Best practices for designing and implementing RabbitMQ-based systems include choosing appropriate exchange types and routing keys, separating concerns with multiple queues, implementing idempotent consumers, monitoring and alerting for critical metrics, load testing for performance and scalability, ensuring message durability and reliability, and following Rabbit's recommended configurations and settings.